In database engineering, I/O is the currency that we deal with. Whether that is an I/O that is going to a mechanical drive or to an SSD drive or to a page in memory, that is cached, or even to the OS file system cache. It's an I/O regardless. Yeah, you can argue that and one I/O can be faster than the other, but it is an I/O. And the goal that we do as database engineers and backend engineers and anyone who build applications is to try to minimize the number of I/Os, being logical or physical. Logical, you can think of logical as I'm hitting the cache, So obviously, one read, one I/O is better than 1 million I/O, even if those million going to the cache. Does that make sense? And the topics of today, one topic. The topic of today, I want to discuss one property in the index that is called FillFactor. That kind of helps minimize the number of I/O depending on your use case, right? And this is a property usually of indexes or any sorted data structure that is a cluster table, which you can argue it's actually an index. All right. How about we actually discuss this? Welcome to the Backend Engineering Show with your host, Hussein, Nasser, and quick shout out before we jump into the show. If you enjoy this content and you can't really watch it on YouTube, this show is available on all your favorite podcasting listening platform. Just Google the Backend Engineering Show. It's available on Spotify, Google Podcast, Apple Podcast, all that jazz. Listen through that and appreciate your support. But just by listening, you're actually supporting the show. Rating the show helps boost it up in all the algorithms that are out there. It's funny that we are being run by robots, if you think about it, really. We're at the mercy of algorithms, which are nothing but AI, and those are robots. The revolution is already here, my friends. We are run by robots. Okay, that was too deep. Let's jump into the show, guys. Another thing I want to mention is if you like my content, consider checking out my courses. I have a few of them. Since this is a database topic, check my database course. So really popular. People like it. It's over 20 hours worth of content. And it's really a course that I wish I had when I was first learning database engineering. I took my experience basically from, roughly in 15 years worth of database experience, 20 years total. And I tried to boil them into, practical as much as, bottom up, so to speak, experience where, okay, we have these things, but why do they exist? Try to link them back up to use cases and useful things instead of, when you're in university, we just basically being taught things. Hey, this is an index. Shut up and use it. This is this and just use it. That is a window size, TCP window size. Yeah, why? No reason. Just learn it and move on with your life. I always was confused about things that I don't know why they exist. And I try to answer the question of a why in all my videos, really. All right, so database.husseinnasser.com is also available right here. If you want to get a coupon for the Udemy course. Appreciate your support. Let's get on with the show. So if we thought about how a table is formed, right? And for simplicity, let's assume a row store instead of a column store, So you have a block of memory and you're going to add your rows, and each row will have a bunch of columns. So they will be padded one after the other, just The first row, all its column. Second row, all its column. So you can see if it's really a rectangle, if you want to visualize it as a rectangle, it will be like this, right? The rows like snake, going multiple rows padded one after the other, you know, and until one page is filled, and depending on the database, page size, MySQL I believe is 16 kilobyte and Postgres by default is 8, and you can change these. So these pages is the unit of work, and that's the minimum thing we can read from database speak. So that's 8K. I don't want to go through actually how that 8K is actually translated to the file system. That kind of complicates the story, because one 8K could be different. One 8K page in the database logical speak is different from a file system page. That's the operating system. So if your database is built on top of the file system, then there is another layer of abstraction, and database engineers try to remove that layer and go directly to the disk as much as possible, to avoid this kind of unneeded abstraction. And what we do, try to sync up this two states as much as possible, the sizes, but that's what we have effectively. And this end up eventually as a page on disk, or multiple pages, or blocks, whatever the name is convention for that device, the storage medium. So the goal here is to write a page or read a page. Let's think about it this way, right? And an IO is the ability to read a page, and you can ask questions like, how many pages can I read in a single IO? And you can barely find any answers about this, because it's so complex of a question, really. And the operating system doesn't have the concept of a pages per se when it comes to a device itself. It says, hey, read me this in a single IO, in a single request. Go and read from this position until this position. And that's an IO, right? So you can technically read multiple pages in a single IO or request, if you will. But regardless, so if the database know that it needs 5 pages, it will send multiple, one request to fetch these 5 pages. Now, I'm not sure, I'm not really an expert in operating system, and those who listen to the show and watches the videos can maybe add to this. I couldn't find an interface that reads multiple blocks from the disk with a single IO. It has to be consecutive, right? So you send a request, okay, read from this position to this position, that's one block, right? And then read this to this, right? Is there an API that allows you to read, okay, here's one interval, if you will, here's another range is a better word, read this range, this range, this range, this range. So it's going to accept like an array of ranges. If I would build something like that, I would build it this way. I would accept an array of ranges. So this way I send one request to the SSD controller, right? Hopefully the NVMe have something like that. I personally didn't see it, but it will say, okay, read this range, this range, this range with a single call. That's how I would build it. I wouldn't build it such that it's like, oh, it's one call and you get one range. This way it will require multiple calls. This is basic API designs, right? But I'm not expert in that area, so I can't speak to what is the current implementation, right? But let's assume you can read, right? This is an IO. So that's the currency. An IO is the currency, right? And sure, you can read multiple pages. Whether this is going to require one IO or multiple, that's out of the question. I hope I get an answer for that, right? I really wish I can speak to, Matthias, who's like the Western Digital kind of spokesperson when it comes to NVMe. I really want to just talk to him. I have so many questions, and fortunately I don't have people who are expert to this. But yeah, I wish we can have that kind of discussion like this. Like, I have so many questions when it comes to these things that I don't have answers. And the NVMe spec is so complex to read, at least for me personally. Maybe I'll get there one day. So yeah, let's continue talking about this. We talked about the concept of a page, and that's not so bad if you add these rows one after the other in this page. You know, they will just be appended one after the other, right? It doesn't really matter, right? That's when you actually add a table. But then if you index, that things then change, right? Because we usually index a column or multiple of columns, right? And what does it mean to really index a column? The beauty of index is to create this structure that we call B tree. And the goal is to sort. That is the most pinnacle important property of an index, that things are sorted, right? And don't think of it like as just a single blob of pages. No, it is actually brilliantly designed for searching as well, not just sorting. But once you land on a page in an index, the column that you indexed, all the values are sorted there. So let's say you are indexing on a column that is called the serial number, right? It's a string, sure. Then that serial numbers that look similar will live in the same page. Right? Let's use that number for simplicity, because we're gonna come to strings and go ahead and UUID. If the serial number is actually serial, like 1, 2, 3, 4, 1,000, 1,001, 1,002, then the page that you're gonna read from an index is, if you're searching for serial number 2000, you're not gonna get just one entry from the index. We talked about this because an IO in the index, in the database, gives you at least a page. There is no byte addressability, you know. You get a whole page or a block, think of it, right? And that page, when you make the query to pull it from the database, because the index lives in the disk, sorry. When you pull it from the disk, the index lives in the disk, just on another data structure, right? Got to persist it. We pull that page and we pick the value 2000. Not only we got 2000, we got 2000, 1999, 1998, and anything after that as well. 2001, 2002, 2003, up until whatever the last entry and the first entry in that page happened to be. Let's say 1800 is the first and the last one is, like, 2200, right? So you get a lot of stuff, and that's good in some situations, especially if you're doing like a range query. If you need those entries, you got them. It's there. You did the IO, right? And that is the important part here. So now, because things are sorted in the index, if I insert more rows, right, then the index is responsible to shove the entry in the right page based on the sorting order. And that is the trick here. Because if I have a page, and let's start from scratch. I have an empty table, and I'm indexing on the serial number here. Yeah. And that serial number is not really a sequence per se. It's not like 1, 2, 3, 4. No, it's just, random values. So if I insert the value, the first row with a value of serial number 1, right? Then a page will be created and the value of 1 will be inserted in the index, and the whole row will be obviously created in the heap and then later flushed to the memory. And the table doesn't really need to have an order unless it's a clustered table, right? So we have two structures, the table and the index. All right, we insert 1. Then let's say I inserted 1000. Well, 1000 is another entry. I have one page. I'm going to insert 1000, right? Because there is a page available. Because 1000 comes after 1, right? So it fits right into the same page. And then I inserted 2000. Right, when 2000 is greater than 1000, then okay, 2000 comes right after 1000. You can see the gaps, not physical gaps, the logical gaps that we have. Because there are numbers between 1000 and 2000, and there are definitely numbers between 1 and 1000. So now, if you continue inserting values like 5000, 6000, 10,000, all of these will go to the same page until that page is filled because it reached the page size, which is 8K, for example, in case of Postgres. And then we're going to insert, I don't know, let's say 2, right? Or for simply, let's say I'm going to insert 20,000, right? 20,000 should go right after whatever the last number, 5,000, but the page is full. Okay, let's create a new page. And 2000 lives exactly next to that page because larger values go to the tail. That's not bad because we're going to the tail. We're going at the end. But what happens if I now insert the number 2? Well, 2 actually comes right after 1, which lives in this page, which happened to be full. You cannot insert the 2 after the 20,000 that we just added. So we have to go back to that full page. And we have to split that page. Where the 1, and then insert the 2 right after that, and then reshuffle the values as a result. So now we have 2 pages with some space left in each of them. That is extremely expensive. And I talked about it in another show, this page split. Okay? And it happens because of the random insert that we did. I don't know what my dog is doing. So just understanding, and I'm sure some of you as they listen to, oh, I have some scenarios like that. Some of you might say, oh, no, don't have any examples like that. If you have a serial number that keeps increasing, autonomous, there is a word for it, autonomously. You know what I'm talking about. Autonomously. Monotonically. I don't know what I'm talking about. Right. So if the values are keep increasing, then the pages can be left alone. You never like to go and split the page because, first of all, it's 2 reads. First of all, it's a get a read, put in memory, do some sort of manipulation, create 2 pages, right? Put the values here, figure out which values go to which page, then flush pause to disk. So that single write inserts will lead to multiple writes, right? Depending on how small and the page will lead to. So it's interesting. GUIDs, or some people call them UUIDs, are nefarious for this. If you index a GUID field or a UUID field, UUIDs are random by nature, right? So if you sort them, then there is no choice, but they will be all over the place, right? If you keep inserting GUIDs, they will be next to each other, but then chances that a new GUID will need to be filled right after a certain GUID based on the alpha. It depends, like what's the data type. If it's a string, then it goes into this, like you use the alphabetical. If it's an hexadecimal number, then you use different byte representation of what sorting comes after that. But that's effectively it, right? And I believe UUID version 4 has some sort of a sorting mechanism. They are naturally sorted when you generate it, as if the first X number of digits are the same. That's nice. I would like to see that. But then I don't know how much collision that you're gonna get with that, right? That's another topic, right? If you know that your UUIDs are sorted, then you're gonna get better performance out of the database because they'll be nicely tucked one after the other, right? But that's just another topic for another day. So that's why I keep saying the UUID, just be careful. If you index a UUID field, just know that this thing exists, right? And keep in mind that this can happen. So how do we address this problem in the index? Well, one solution that we came up with is to introduce a fill capacity in the page for indexes, because it doesn't make any sense for heap, right? If it's unordered, right? Because it's unordered, I'm not going to enforce any order, right? But FillFactor has been introduced as a percentage. As you insert, if you create a new page, and as you insert values to this page, once you reach 80% of that page, stop. Don't use it anymore. That's the trick here, right? If you reach 70%, that's the FillFactor 70%, keep filling the page until 70% of the 8K. Once you reach that, leave the space unfilled and then go to the next page. Given that you can actually do that, what does that mean? Right? If you're gonna insert 1, 2, 3, 4, 5, 6, blah, 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 10, and the page reaches 70%, then you want to insert 11. 11 should come after the 10, right? Then sure, that will basically create a new page, leave the 30% free, right? So now if you insert the value 11, just go to a new page, right? And 12 goes to the other page, right? That. But then if you want to insert the value, I don't know, 3, let's say we have 1 and 2 and 4, but we don't have a 3, you can use that page. You have to. Use that page. So you have a little bit of a wiggle room to grow in that page. And that is the most important thing in a FillFactor representation of an index, where you have at least, you avoid splitting the page because there is room to insert in that thing. Okay? So you want to leave room in the index if you have random inserting values, right, in the page. Things like GUIDs, or UUID that are actually random, or even integer numbers that you know it's random. This is going to be coming in a random fashion. Then having a FillFactor of 80%, it depends. It's all, at the end of the day, it's all subjective and really depends on, I guess, use cases and testing and trial and error. I can't give you a number, to be honest, right? So I tried 80%, I have 70, I have even 100%. I'm going to talk about it. You have to, sometimes the FillFactor is actually a double-edged sword. We're going to come to that in a minute. Hopefully I don't forget. So what will happen is you're gonna end up with these things, right? So you need the random values that get inserted. You need some space so that just in case I had to insert a value between two values that happen to be in the same page, I have room to grow. That's the purpose right here. Okay. But let's talk about when FillFactor actually is a detriment to the index. Let's say I use a FillFactor on a sequence, on an integer field that has a sequence. That means every value that you insert is always increasing by 1, right? So 1, 2, 3. There will never be a gap at all, right? Assuming this is natural numbers, obviously an integer, right? So if I insert 1 and 2 and 3 and 4 and 5, 6, and I had like a FillFactor of 50%, that is absolutely will degrade the performance. Why? Because this is increasing. This is continually increasing. So that means you're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And let's say the maximum is 20. You just left 50% empty. Then 11 will go to a new page. Why? Why don't you put 11 on the same page? Right? We're going to continue. Okay. 11, 12, 20. Right? Use another page. That really will kill the performance. Why? You see, because now, back to our currency, which is the IO. I keep slipping my chair. Our currency is the IO, right? If I want to read a range query in my index, give me all the values, all the rows that between 5 and 300, right? My index will go to that page and fetch it, right? It will find a page that has 10 numbers, but it will also have half of the page, 4 kilobyte of the 8K, is null, is all zeroed out, which is absolutely useless for me. Obviously, I need to continue reading, so I go and read another page. Oh, we got now 10 to 20. Ah, the rest is empty. Oh, what a shame. Now you keep reading blank, useless data. You're spending money, currency, to read half of the data. So in that particular scenario where you know there will never be gaps, dates is another example. If you have logs that like you're logging something and you know that you'll never go to the past and insert something in the past, you never do that, FillFactor should be 100%, right? You have to use FillFactor 100%. You fill that page, make it cram it with content so that just one single IO gives you as much possible data as possible, right? So we want FillFactor sometimes to be 100%, and sometimes we want it to have a little bit of a wiggle room, right? My money don't wiggle, it falls. That's a poem I wrote, by the way. I'm just kidding. Song is everywhere. My brain is melting. Okay, so FillFactor. So let's talk about final thing, fragmentation. A fragmented index is kind of a result of kind of similar to this. Let's say you have a nice, beautiful page with a lot of entries, and you start deleting, blah, 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 delete. Or even in case of a Postgres update. Postgres might be smarter in update, so I'll take that back. But if you delete rows, or even update all the rows, right? Then you're gonna have rows that are orphaned in the page, right? So you can have 1, 2, 3, and then deleted, and then 5, 6, 7, deleted. So this is very similar to when the FillFactor is a very low value, and then you're gonna read values, right? Only to find that most of these rows has been deleted. So that's a waste of money, right? Of currency, because IO didn't give me everything I need. What's the goal? What did I say when we started? We want to make the least minimum number of IOs. We want to spend the least amount of money, right? Currency. IO's currency. Every IO you make, a duck dies. You kill a duck. So try to minimize the number of ducks that you slaughter, right? In this process. So now in a single IO, if you have all these deleted rows, then that's also wasted. So re-indexing really helps here as well. Okay? If you re-index your table, that's probably all database engineers are familiar with that. Your performance increases, especially if in a heavily edited table where you're just changing all the time and editing all the time, right? But then also, that is not always true, because deleted rows, if you read a page that has some deleted rows, if I'm an old transaction and my isolation level is repeatable read, or serializable, or even read committed in certain areas, I might have need these deleted rows because I started a long time ago, right? And I'm not seeing. I need to see these values for a certain read committed might not be the case here, but definitely repeatable read. So hey, I started a long time ago. I need to see these deleted rows, right? So you can't always physically remove this entry from the index. Sometimes you keep them. That's why a lot of database experts. I'm not a database expert. I don't like to call myself, because there is so much to learn. It's like we were talking about the IO in the beginning. I didn't know anything about that stuff yet. So I don't like to call myself an expert at all. So a lot of people who knows about database engineering, they advise against long-running transactions. because those long-running transactions will hold sort of special locks on these deleted rows that vacuum, in case of Postgres and other undo log, cannot physically remove them at all. It has to stay there. And if they are there, new transactions suffer, because new transactions, they don't have business of these deleted rows. To them, they started after the row has been deleted. So their snapshot is reading from that state, right? So they don't need, there is no business. So long-running transactions are holding back the system. So fragmented index is a thing. Page splits is the thing. So as a summary, we're going to summarize this. FillFactor is a very nice property, but it's a double-edged sword. Make the FillFactor too small, and you might suffer from, expensive reads that don't have as much juicy data. Make it full, 100% or too large, then you might suffer page splits. And page splits also, expensive, It's like you're taking a saw and then you saw the page in half. Very, very painful to the database, Sometimes databases have feelings. You have to care, my friends, about the database feelings. And then you want to leave, I'm looking at my bullet points here, so I don't have a script or anything like that. Just literally have like 4 bullet points with 3 words in each one. And so sometimes you want to leave it 100%. You want to leave it, make it too small. Sometimes you got to worry about the fragmented index. That's another thing where as you delete, you need to re-index that. I don't know if FillFactor helps with fragmented index, to be honest. I think a small FillFactor will result in a fragmented index in a sense, where you're going to have these empty pages that your index will be too large if the FillFactor is too small, and your values are monotonically increasing. I'm pretty sure that's the word. And you guys are yelling at me, It's just keep increasing. It will never go back and insert an old value. Dates are another example, right? So yeah, guys, what do you think about this? Are you using FillFactor? I keep saying, I keep thinking of FillFactor, Fear Factor, the show that Joe Rogan was on, Fear Factor. It's like it always confuses the two. All right, guys. Hope you enjoyed this episode of the Backend Engineering Show. Consider becoming a member. It supports the show, keeps the shows going, Consider using this super thanks in YouTube. Keeps the show going. Consider getting my courses. Database. I have a database course. I have a network course. Check them out. Go to my database.husseinnasser.com, network.husseinnasser.com. Just go to my website. You're going to find all my courses there. We have all sorts of great community here where we have great discussions. I try to sometimes reply when I have the chance. But with a new baby now, he's a toddler. Yeah, he messed up my mic, so I don't know if this. Hopefully the audio is clear, because he now can stand and walk everywhere. So he went to the audio interface and started just tuning. He like anything that has a rotate, he would just flip it right and right. So I have no idea. I tested it. It sounds good, but hopefully this audio is good. Appreciate all of you guys. Thank you so much for all the support. See you in the next one. Goodbye.